The James Webb Space Telescope has done it again. Floating 1,000,000 miles from Earth, beyond the interference of our atmosphere, it peered deep into the Alpha Centauri system and turned its powerful gaze onto Proxima Centauri b, an Earth-sized exoplanet that orbits the star closest to our solar system. What it found has left the scientific world stunned and scrambling for answers. Over the course of several nights, data gathered from Webb's highly sensitive instruments showed a staggering 270% surge in visible spectrum emissions from the planet's dark side. These emissions did not resemble natural geological activity or auroral displays. Instead, their wavelength and temporal pattern uncannily mirrored the type of urban lighting found in densely populated human cities. In other words, something or someone might be illuminating the night on Proxima b. Before we start, smash the like and subscribe buttons for more updates. This event marks the first time in recorded history that an astronomical instrument has captured evidence suggestive of artificial lighting on an exoplanet. The surge wasn't gradual. It was sudden, sharp, and sustained across multiple orbits of the planet. For context, Proxima b is a tidally locked world, meaning one side always faces its star while the other remains in perpetual darkness. That dark side, until now presumed to be inhospitable and frozen, suddenly flared into luminous life, as though some hidden civilization had decided to switch on the lights, or perhaps had never turned them off in the first place, only now becoming bright enough to be noticed. Researchers immediately ruled out known natural sources for such a sharp increase in brightness. Volcanic activity could not account for the spectrum or consistency of the emissions. Proxima Centauri, a red dwarf star notorious for flares, was calm during the observation period. The only signal that made sense, however astonishing, was one akin to artificial lighting consistent with massive population centers that light up our own planet when viewed from space. The difference here is the scale. A 270% increase isn't a flicker or an isolated event. It's the planetary equivalent of an entire continent lighting up overnight. The implications of this are mind-altering. For decades, the search for extraterrestrial intelligence, SETI, has been marked by silence. We've pointed radio telescopes at the stars, listened across the void, and received no clear message in return. But this is not a message sent to us. This is a civilization going about its business, unaware or uncaring that someone is watching. The surge in light may not be communication, but it is information, and information, when interpreted correctly, can be just as revealing. One of the most electrifying aspects of this development is its implication for habitability. Until now, Proxima b was considered a maybe in terms of life potential. It orbits within the habitable zone of its parent star, meaning it could theoretically support liquid water. But the tidal locking and high stellar radiation from its flare-prone sun made scientists wary that life would have a tough time on such a world. Or so we thought. The idea that there could be infrastructure capable of generating that much light not only suggests technological advancement, but a solution to environmental challenges that we once considered deal-breakers. A civilization might have adapted to the harsh conditions, constructing habitats on the dark side away from stellar radiation and using artificial lighting to simulate daylight cycles or power agriculture. Speculation is now rampant in both scientific and philosophical circles. Are we looking at an alien version of Earth cities, with networks of illumination strung across a planet's surface? If so, how old might such a civilization be? The scale of light production implies an advanced energy infrastructure. On Earth, our light pollution is powered by everything from fossil fuels to renewable energy grids. On Proxima b, under the freezing conditions of eternal night, only a well-established technological base could generate and sustain such power, whether through nuclear energy, fusion, or some other unknown method. Whatever the source, the existence of such lighting redefines our assumptions about where and how intelligent life could evolve. Then there's the question of intent. Was this surge deliberate? Could this civilization have detected us and decided to reveal its presence in a subtle but unmistakable way? Or was it an accident, a byproduct of internal development that just happened to become visible now due to expansion, new construction, or a population boom? Either way, it represents a new chapter in our understanding of the cosmos, not just a world where life might exist, but one where civilization appears to thrive. Beyond the philosophical shockwaves, practical concerns are beginning to emerge. Astronomers are racing to confirm the observation through other instruments. While the James Webb Telescope's data is highly credible, confirmation through independent sources like the European Extremely Large Telescope, ELT, or the upcoming 30-meter telescope, TMT, would cement the finding. Spectral analysis is already underway, with researchers dissecting the emissions for chemical markers, light patterns, and temporal rhythms. If the illumination fluctuates in regular cycles, if it dims at what would be a night for them and brightens again at a corresponding day, then that would further strengthen the case for intelligent design. There's also the tantalizing possibility that we might be able to resolve surface features on Proxima b within the coming decades. Advances in optical interferometry and space-based telescopic arrays might allow us to literally see the source of this artificial lighting. Imagine for a moment the first blurry image of a cityscape on an alien world, a skyline rising against the frozen dark side of a distant planet. That kind of visual confirmation would be transformational, not just for science, but for our species' collective imagination. Governments and space agencies are watching this development with intense interest. The idea that we might not be alone has always been part of the public consciousness, but this is different. This isn't fiction or folklore. This is data. Cold, hard, astonishing data. And with that data comes responsibility. How do we approach a civilization that might not know we exist? Should we attempt to communicate, or should we remain observers cautious, not to interfere with something we don't yet understand? Many are urging restraint. After all, just because we see lights doesn't mean those behind them are friendly or even biologically compatible. The technological disparity might be vast. What we're seeing could be remnants of a civilization long gone, their automated systems still running like ghosts in the night. Alternatively, they might be watching us just as we are watching them. The implications of mutual observation, too. Intelligent species staring across 4.24 light-years are profound. Religious and cultural institutions are also grappling with what this might mean. The existence of a civilization on Proxima b challenges long-held anthropocentric views about life's uniqueness. It could redefine our place in the universe, shaking the very foundations of belief systems that have endured for millennia. Yet for many, it's also a cause for awe and humility. That we are not alone means we are part of a larger, interconnected, cosmic tapestry. And in that vastness, there is room for wonder and for responsibility. Education systems may soon need to incorporate these findings into their curricula. Imagine children growing up in a world where alien cities are not a matter of speculation, but of scientific fact. Entire disciplines may emerge from exobiology studies to interstellar diplomacy. What began as an astronomical anomaly could blossom into a multidisciplinary revolution, reshaping how we study history, sociology, architecture, and even ethics. Meanwhile, back at home, the public response has been electric. Social media platforms are ablaze with theories, excitement, and, of course, skepticism. While conspiracy theories always flourish in moments like these, the availability of raw observational data is helping science communicators get ahead of misinformation. And for many, the light on Proxima b is a beacon of hope in an age often defined by terrestrial conflict and environmental crisis. The idea that somewhere out there life has not only survived but flourished offers a vision of persistence, and perhaps a model worth studying. Technologically, this moment is a vindication for the billions invested into instruments like the James Webb Telescope. Often criticized for cost overruns and delays, the telescope is now delivering results that justify its ambition. It's not just a window into the past. It's a window into possibility, and in that possibility lies the next great frontier of human exploration. The revelation also underscores the importance of continued funding for next-generation telescopes and interstellar probes. The prospect of sending a flyby mission to Proxima b, once a theoretical exercise, now carries real weight. Projects like Breakthrough Starshot, which propose sending microprobes at a fraction of light speed, are receiving renewed attention. This surge of light has effectively redefined the priorities of exoplanet science. No longer is the focus just on locating habitable zones or atmospheric composition. Now, there is a new metric: technological activity. The search for technosignatures, once a niche field, has suddenly moved center stage. Urban illumination, power grid emissions, and industrial pollutants are no longer science fiction topics, but real phenomena we must learn to detect and interpret.